Hello everybody, we are Team November and our project was Sailing by Sound. Now, to explain what our project was, let me first give you some context. Some of us have indeed tried sailing. I tried it a few years ago and it was a very fun experience. And as technology marches on, newer yachts and boats have a wider array of more modern digital sensors and navigational instruments. Now, the big question is, how usable are these instruments? Well, if we have a look at this one, wind compass, wind speed sensor, it seems fairly intuitive. However, it is inherently visual, which makes it not appropriate for visually impaired people, among these being people who are completely blind from birth. Statistics show that several million people in the UK alone suffer from some sort of vision loss. So, our goal was to provide some sort of system that will provide voice output for accessibility. And this is what we have done. And this is what the system we have built looks like. Top down, it is just a grey waterproof box that has some cables sticking out of it. You just plug it into your navigational pad that you would have on your yacht, and it just works. You've got 6 buttons that are clearly labeled in Braille, and they provide you with the necessary information. The way our system is used is you boot it up and it will self-start. It will also perform crash recovery. You've got the 6 buttons, all of them providing some sort of information. Some information is obvious, such as boat speed, boat heading, wind speed, wind angle, and water depth, which you would usually find on your navigational pad or something on a yacht, but in a visual sense. These are obvious. However, if you're sailing in the open seas, maybe getting GPS coordinates is not entirely intuitive if you're a visually impaired person. So we decided to implement a feature that gives you directions to your nearest port. And as you click on one of these buttons, you hear a lovely voice tell you what you're supposed to know. To make the system as accessible as possible, we need to implement some sort of an alert system. An alert system is needed because it could be the case you have some sort of critical sensor readings or a sensor malfunction. Critical sensor readings might mean something like, oh, the water depth is too low, or you're going way too quickly. And a sensor malfunction might mean, oh, you haven't gotten any data from your wind speed sensor in a while. So an alert is just a regular voice message you would get from a button, but has a greater priority than the usual message, as in it can preempt the button messages. And we hope to prevent some sort of a disaster in this way. And this is what our system looks like under the hood. It is just a mess of wires, but if you look very closely, you will see 2 speakers and a Raspberry Pi in the middle. All of the software that we wrote was implemented on a Raspberry Pi. The main purpose of the Raspberry Pi is to store the internal state and to communicate with the navigational instruments. It is a standard protocol for navigational instruments, the NME 2K protocol, which unfortunately happens to be proprietary. And buying the license to use this protocol and to see the specification cost something like £4,000. So that was out of the question. However, there exists an open source effort to reverse engineer the system, which is called CanBoat. So we just use that. We also use the Pi4J library in order to interact with the buttons. Most of our software was written in Java. Some of it was written in Bash, such as the startup and crash recovery system. And we made full use of some existing libraries, such as Pico, which is the text-to-speech engine which is used by Google's Android operating system. Now, for demonstration and testing purposes, it is very difficult to get a boat, especially get it upstairs in the Intel lab. So we decided to create some sort of a simulation which will provide us with some sort of idea what is going on, and also create packets which resemble the NME 2K ones. And we're good to go. It works under heavy load as well. And to prove our point that we actually had something that resembled real data, you can sail around the world. It's a flat Earth though, so it's fun. You can find all of our source code on this GitHub repository, and we did our best to document it as much as possible and to be as neat as possible. You can find all the necessary install and licensing instructions there. Thank you very much for your attention.